We're really lucky to have Professor Michael Shawn Fletcher come to speak to us today from the University of Melbourne. Michael's what do you call it, a paleobiogeographer? Something like that. He's also a Radjary man and a good fella. Thanks, bro.
Thanks, mate. It's a bit bright. Okay. First I'd like to acknowledge that a lot of this work was done on Gadimanoo country. I live and work on Bunurong and Wurundjeri country, so I'd like to acknowledge any mob that are here. So to try and get a handle on where we are, we need to have a bit of a think about where we've come from. This is my life's work really, is looking at long-term environmental change. And it's kind of, I guess, a bit of a salve, but also has its own problems for what you could call the myopia, I guess, of neo-ecology. It is ecology that's focused on the recent past. I'm going to stuff this up. So here's, I made this up, right? It's not real data. Tree cover going up and down through time. Serious ecology. I think you'd be lucky to find a 40-year long-term ecology plot in this country. Really encompasses too short a period of time to understand the true amplitude of change that ecosystems and environments operate at. Okay, if we think about some of the trees I work with in Tasmania might live to 2,000 years. So you're really taking a little snapshot of time. So what paleoecology, okay, Greek prefix for past, does is try to get a longer term view of how things have changed. In doing so, we sacrifice, I guess we suffer from hyperopia, which is we miss out on some of these fine scale variability. So by joining the two, the kind of short-term processes that we can glean from neo-ecology, merging that with paleoecology, we can hope to get a fuller understanding of how the world around us operates. Okay, I'll do it again. I work in wetlands. Okay, I figured a lot of people probably don't know what it is that I do, and I don't want to go too deep into the unknown and lose you all. So I've got a 2-minute video after this. Here's a core. It's kind of upside down, I guess. That's the bottom, that's the top. So I take these sediment cores from the endpoints in depositional environments, and the whole notion here is that all the stuff that's blowing around in atmosphere, sitting in a landscape, eventually finds itself either into the ocean or into a lake or a bog or a swamp. And that is a reflection of the environment at the time. Okay? Plants produce pollen, fires produce charcoal, little bugs are flying around, all this sort of stuff gets trapped in the sediments of lakes and bogs and swamps, gets preserved, and we can pull that out just like an ice core, except on land, and we can piece together how environments change. To do this, we need some specialised equipment. Here's an example for those who don't know. That's Naarm, that's Melbourne in the background here. And this is a billabong. This is actually the place that the Wurundjeri chose to be relocated as Melbourne was expanding. Of course, they were told no, and kicked off to Nari Warren and then Corranderk, but this is Bulleen, or Bolan Billabong. It's just a bit of an idea of what's involved in what we do. So various places need different apparatus. This is a platform we build, and we're just basically very technical. We're going to bash this pipe into the ground. Yeah? It's got a piston in it, stops compression of sediment and all this sort of stuff. It's a bit more technical than just that, but essentially it's just bashing a pipe in the ground. We pull that out, we'll take it to the lab, and we'll do all sorts of things. And essentially, our process in the lab is to split the core. It's not moving fast enough for me now. Split the core, chop it up. Sometimes we need to split it under red light to maintain the optical properties of some of the grains in the cores. Then we disintegrate everything we don't want using a various array of different chemicals. Some of the most dangerous chemicals on campus, really. If anyone's seen Breaking Bad, it's if you want to get rid of a body, we use that stuff. Okay? And the money goes to my consultancy fund. So we isolate what we want. Here's Anthony getting ready to melt a body. We then pull out the things that we want to see. That'll be either pollen or charcoal or insect head capsules, diatoms, geochemicals, all these sorts of various things that tell us about environmental change through time. So here's some charcoal. Also look at pollen grains, and you'll see some pop up on the screen, and we can get these either down to species or genus or sometimes only family level, but they tell us they're really powerful means, highly quantifiable means of past environmental change. And they're just because we want to feel like scientists, we do statistics, because everyone knows that statistics are objective and they tell you the truth. Okay, and we can reconstruct the past. All right, so where are we coming at here? Well, there's a fact, and this is a fact, that the maps that we use for restoration, okay, or for environmental accounting, such as the State of Environment Report, are almost always wrong. Here's a 2005 EVC of the Carlisle Heath where this work's done. And apparently in 1750 it was exactly the same. Okay, and you see this commonly across the landscape, right? If we think about the importance of this, I mean, the first principle of the National Standards of Restoration is that we know what we're restoring to. Yeah, that's an absolute principle that we must abide by. Okay, well, is that true? Okay, so here's the Carlisle Heath. I'll whip you through this. There's 4 sites here, very high level. The one thing I did, and maybe some of you can consult me, I've got some dating issues, right? Not those ones. So, and it's prompted me to think outside the box. It's been good in the end, but it's a bit of a pain in the ass, really, for this work. It's slowing things down. Is that we use radiocarbon dating. You've probably all heard of that. That's assuming that the stuff you're dating is contemporaneous with the stuff that you're counting. Okay, you're counting pollen laid down in this layer of sediment. You assume that you're dating things that are that old. But in a place like Australia, where you have charcoal sitting in a landscape for thousands of years sometimes and slowly being delivered into lakes and being deposited in with your pollen, you can get some spuriously old ages, and that's what's happening. So normally we would date nice leaves and things because they break down really quickly and they are contemporaneous. But we're getting some really weird old dates that are just way too old to be real. So it sort of pushed me into the direction of flow cytometry, for those who don't know, cell sorting. So now we're experimenting on actually extracting pure pollen extracts rather than the crap we count through, which contains everything, charcoal, bits of all sorts of things in there. So that's just a caveat that around this work, that it's not, some of it's dated really well, the rest of it I'm going to show you just by depth. Okay, I'll just show you some data, right, and we'll see what it means. This is how I view the world. Okay, this is time. Time goes this way. Okay, from old 1400 Common Era to 2023. These calls were taken at the start of last year. These are trees, principally eucalypts, shrubs, principally melaleucas and tea trees, herbs, your graminoids, I think we just heard, and then tea tree are included in this some, okay? Just extract our leptospermum out from there. So what can you see here? You can see this grey shading here is the approximate period of the British invasion, okay, which began in the 1800s and really in earnest around 1840, where there was a series of massacres over the previous decades. And there just so happens to be a lot of fire then and a shrub expansion afterwards. Interesting. Think about what that means after. Now, this is depth, so I've run it the other way, okay? This site will likely be old. We've got a fairly robust date here, about 3,000 years ago. We've dated this quite well, the present, so we know when invasion was. These are exotic pollen grains, and it matches up well with our shorter isotope dating methodologies. I've plotted it by depth. This is charcoal going through here. Here are eucalypts. We're interested in Murnong at this point in time. This is grass, she oaks or whistling oaks. And this is just to show that the site was once a forested bog and turned into an open water environment, which it is today, sometime before 3,000 years ago. Take-home message here is that we hit the highest amounts of charcoal in this open water phase following a massive expansion from 20 to 50% eucalypts, okay, in the post-British invasion period, signalling more fire in that period, just like the last one. There's another site which is along there, and you can see depth once again, exotic pollen here. This is independently dated in the recent period with those shorter isotopes of lead. Here's the invasion window. You can see here that shrubs are increasing, trees are decreasing. There's a sum data, so percentage data, so they're going to be artefactual. And the key point here is we have lots of charcoal towards the end, more than there's been over the entire period. Next site here. It's interesting, it's open water now, look really lovely. At some time in the past, prior to the British invasion, it shifted from a shrubby wetland to an open water wetland. We know this because of the changes in algae and things like that. What we can see here, there's no corresponding change in shrubbiness, okay, but once again, this is proportionate data. What we need to do once we get a robust age model is we can estimate how biomass has changed. So you can keep the same proportion of plants, but the amount of them might change, okay? So that's something we need to investigate when we get some more robust dating, hence the caveats at the start around my dating issues, not my personal life. Okay, so as I said, a really high level take-home message. Over 3 sites, shrubs or trees are increasing in the post-British invasion period, more fire in all of the sites in the post-British invasion period. This fits perfectly within some recently published work from all across mainland Australia, irrespective of the current vegetation, where we see a region-wide expansion of shrubs following the removal of cultural burning from the landscape and a subsequent increase in catastrophic fires. Fits with some recent work at a grant we've just wrapped up, 3-year grant we've just wrapped up, which we'll be publishing soon, which is sites within extant forests ranging from, there's a bit of a gap here, but Bundjalung country right through to Wadawurrung country, where, I don't know, it's a bit complex this here. If we just, if the line here, the event that we're looking at is the British invasion, you can see there is a massive explosion of eucalypts in the post-invasion period. There are substantially, and in some places, such as here just south of Evans Head, there are 6 times more eucalypts in this forest now in Bundjalung National Park than there were under Bundjalung care and management. Okay, there has been a massive expansion of eucalypts. Okay, here's some timings for you. Okay, British invasion. That's at 1788. The next thing that happens are the massacres of Aboriginal people across Southeast Australia, reflecting a disruption of cultural lifeways and cultural burning. The next in the sequence is that eucalypts expand, and these have all been identified using breakpoint analysis, and it's not just me drawing a line on the graph. The next thing that happens is that charcoal increases across the region, eucalypts, charcoal, and then just here, just to temper the obsession I see, and don't get me wrong, don't walk away thinking I'm a climate denier. I fully believe that climate change is a problem and it's exacerbating catastrophic fires. But these things happen before the effects of climate change. Yeah? And here's a series of these sites. This is the eucalypt expansion happening well before, in all but one site, okay, before the onset of anthropogenic climate change. Okay, so the sequence is British invasion, eucalypt increase, this is in these sites, shrubs more broadly in places like the Carlisle Heath, fire increases, climate changes, and then you get more fire, okay? I think I want to go here. I know I'm standing between you and lunch, so it's always a bit dangerous, right? But yeah, I can't, if you went to the doctor with chronic headaches and the doctor said, here's some Panadol, off you go, right? You'd be pretty annoyed, right? You want to get down to what the symptoms are, right? So at the moment, if this is a fire triangle, if you change climate in a certain way, you get more fire. And we are completely obsessed with this at the moment, right? We are, and it's true. We're getting more fire danger, weather, all this sort of stuff, and it's causing more fires. But you can get the same result if you add more fuel, yeah? And if you do both, you end up here. Now, we've got the sites on the decades, maybe century-long ambition of reducing carbon and bringing climate back under control. Good on us, we should. But we can get more immediate results if we think about the fuel and lose our misguided belief of what this continent was like prior to the British invasion, okay, and what we think, or our obsession basically with trees. Okay, and there's an interesting paper in Trends in Ecology and Evolution about the obsession that humans have with trees, counter to our own evolutionary pathway, which is as a savanna organism that is dependent on grasses. So we have a cultural problem, okay, one of lost connection with fire, where we should be looking at it like this. This is how we look at fire, okay? Okay, we have paramilitary organisations. We're fighting the very thing that we evolved with, okay, that we walked hand in hand with for 1.4 million years, okay, well before Homo sapiens evolved. And we have myopia, okay? We plug in the wrong endpoints, okay, into our restoration, which exacerbate the problem. That's it.
Thanks, bro. Maybe one quick query before lunchtime. Is that, I can see a hand raised up the top there, Tim. You got it.
G'day, Michael. Really great talk. Are you aware of similar data from elsewhere in the world, say from the Americas, for example, that shows similar trends after European invasion?
Yeah, definitely in the Americas. And they've actually got really cool data sets there where a lot of their trees are datable by dendrochronology. And you can really see these discretely date. I work in the era of, it's good for me, I can make up stories and I've got an era to play with, Whereas this dendro work, you can actually just see a massive forest expansion across parts of North America, and you see in those really fire-prone, kind of chaparral, all those other sorts of areas that are really fire-prone, you see the same kinds of trends, yeah. And the same conversations are having, I have it with North American colleagues around the same thing. And in Africa as well, you see these things in Africa, so. I mean, it's weird, I don't want to pick on Europeans too much, but idiosyncratically, they lost the need or the connection with fire, and then suddenly that ethos teleported around the world and imposed this anti-fire ethos. Okay, and now and I see this all the time, and no discredit to anyone doing this, even the fireys out there, they are amazingly brave people. My shot isn't at them, it's about the cultural paradigm that underpins all this, right? But now we've got people wielding sledgehammers where people used to be surgeons with fire, And those surgeons are still here. Tap them on the shoulder and say, "G'day, can you give us a hand?" So,